Hello, today we're going to talk about the riveting topic of CDN configuration management. My name's Glenn Goldstein. I've been a streaming technology leader for many years, taking the journey across the various streaming protocols you see there, all the way from real media, the turn of the century, up to MPEG-Dash in recent times. I've been a CDN customer in many years at MTV and Viacom, and now as a CDN provider at Lumen, which many of you may have known from its former names of CenturyLink and Level 3. And as a CDN customer at MTV and Viacom, I certainly felt the pain of managing many CDN configurations, and it's not a lot of fun. So we're going to try to fix that. I'm also a member of the Streaming Video Alliance for Lumen, and SVA is a global organization, about 100 members working on technology challenges around streaming video. And the open caching working group within the SVA focuses on open caching technologies, which we'll get a lot more into now. So clarifying some terminology, all of this stuff is built on top of CDNI. That's an IETF standard that defines interfaces for how upstream CDNs can delegate requests to downstream CDNs. Open caching is a specific use case, really, of CDNI, where the upstream CDN may be a commercial CDN or a content provider, and the downstream CDN is an ISP. All of these things need configuration metadata that typically defines how origins are accessed, authentication rules, transformations. On the open caching use case, there's additional metadata needed to communicate telemetry of capacity, footprint availability, etc. And of course, interchanging all of this metadata is of prime concern and really essential for interoperability. CDNI, just to drill down real quickly, as I said, it defines a set of interfaces for interchanging metadata around delegating requests, and the actual request routing interfaces to delegate requests. Typically, requests are delegated either via HTTP redirects or DNS. Like I said before, the roles here can be fluid. Content providers, CDNs, ISPs can play a variety of roles in this ecosystem. The SVA open caching reference model really calls for a set of open caching controllers at the service provider, at the ISP, and at the CDN. And content providers will typically hand off requests to a CDN, which will then delegate the requests to the particular ISP through a set of APIs and protocols for service discovery, caching and control, logging, and request routing. So the challenge for configuration metadata is really creating an industry standard for representing the model, first of all, what are all the configurable items in this type of system, and how the configuration data gets published. Publishing configurations to a production environment, rolling back, etc., cloning, versioning configurations. These are all big problems in the industry. There's many motivations for solving this problem and standardizing, and within the SVA, our membership that includes content providers, CDNs, ISPs, open caching technology vendors, all agreed on a set of motivational drivers that really set the stage for this project. Standardizing of feature definitions, making integrations more efficient, obviously making the whole thing more DevOps friendly and automation, and also still creating opportunities for technology vendors to differentiate themselves, and we get into that through a thing we call private features. So what we wanted to do is kill two birds with one stone. Sorry for the terrible metaphor there. And open caching systems need configuration metadata. CDNs also need configuration metadata. Typically, in that world, it's content providers configuring CDNs. So our realization was, let's solve these things together. And let's look at the IETF CDNI standard as a really good starting point for a configuration data model. So the result was about a 15-month process within the SVA to collaborate and negotiate what these capabilities should be, how they should be represented. And it really wasn't like herding cats. There was really a large incentive on everyone's part to cooperate and collaborate on this thing. So why couldn't we just use CDNI metadata right out of the box? Well, it was a good start, but when CDNI metadata was authored, it was contemplating relatively simple use cases. And as we get into looking at all the things commercial CDNs do for content providers, there were just many more capabilities that needed to be represented. Also, the publishing model in CDNI was pretty simplistic, generally allowing downstream CDNs to query upstream CDNs for metadata, We wanted to go the other way around. We needed a way to publish metadata downstream, so we needed to deal with that. And also just adding publishing, versioning, controlling, deployment controls. All of that was really sort of absent in the CDNI model. So we aim to close all those gaps. So here's what CDNI metadata looks like, just at kind of a high level. RFC 8006 is the document that defines the metadata model, and that's really our starting point. In this example here, you've got a host index. So these are all the hosts in the configuration. And you can have metadata at the host level. So for example, if there's a request to www.tunes.example.com, that up metadata box there hooked onto it, that can define all the metadata. You can also override metadata at a path level, and you can have multiple levels of inheritance. This structural metadata that we're looking at here, we didn't touch any of that for SVA. We thought it was important to leave that core portion of the CDNI model alone. We knew that would also increase our chances of getting our proposals through the IETF. We'll talk more about that later. And the model has a thing called a generic metadata object, and that really is the vehicle for extension, and that's where everything we did lives. So what did we propose adding to the metadata model? Several large categories of work. Really, a lot of it around enhancing the definition of a source or an origin in CDN terminology and how the source can be accessed. We defined some load balancing capabilities to load balance across multiple sources, failover across multiple sources. We added several authentication methods like the AWS authentication method, things that are all standard practice in the commercial CDN industry, but CDNI, was kind of silent on. We added a bunch of cache control policies, negative cache control, cache overrides, ways to dynamically compute cache keys. Mechanisms to dynamically generate CORS headers. Certainly in the CDN environment, that's an important feature. Definitions of traffic types like live and VOD and catch up that hint the CDN towards certain behaviors. Service IDs. As I mentioned, the SVA open caching layer had its own configuration needs, mostly around moving capacity and footprint information around. Private features allow for extensibility. And the biggest thing we added was a whole processing stage model and expression language. So what this model does is define 4 key points in the CDN workflow between clients and origins for any given request. When the request comes in the front door, that's A there, client request. When the request goes to the origin on a cache miss, when the response comes back from the origin, and then when the response goes out of CDN cache back to the client. And at each of these stages, we've added an opportunity to conditionally add metadata or processing rules that may transform a request or a response or generate a synthetic response. So let's look at some code. Here's an example. This is a complete example for a host named edge.example.com. It uses the processing stages thing that was added with a query with the expression language saying if the status code from the origin is a 200, then go ahead and set a cache policy that will set downstream to the client, upstream to the client, don't cache, but still maintain an internal cache of 5 seconds to prevent an origin from being overwhelmed. So that's a typical example of how the SVA extension, in this case, the processing stages and cache policy extensions fit into the standard framework of the host's configuration structure. So some specification documents to talk about. Within the SVA, we've put out a 3-part specification that covers all of this. Part 1 is really just an overview. Part 2 is very specific around the extensions to the metadata model, really things that we want added to RFC 8006 in the CDNI spec. And Part 3 is publishing APIs, starting with a very simple API, which extends what CDNI had originally proposed, just basically put and get of configuration JSON blobs. There also will be an advanced API that will deal with much more of the full lifecycle management of configurations, publishing, versioning, rollback, etc. That work is just starting now. And all of this is now open to public review, and we're going to want your feedback. So go to streamingvideoalliance.org, and you can find out how you can comment on these specifications. Also, our documentation using the Open API standard that define these APIs in industry standard fashion. And finally, we have the IETF draft for how we want to extend RFC 8006. So the skeletal draft was proposed at the IETF 111 meetings back in July. Feedback was pretty positive. I don't think they're going to take all of it. They might not take processing stages. And now upcoming in November, we have IETF 112, where we will propose to move this thing along further. So thanks very much. Hope that was informative.